In this video, we're going to look how to do some triangle proofs. So in this case, we're trying to prove that these two triangles are congruent. And so what we want to do is figure out there are several theorems that can prove triangle congruence. So you want to look at all those, and we're going to try to get one that will work. So first off, we're going to take our given points. So it says C is the midpoint of BD. So if C is in the middle of this segment BD, then we know that segment BC is congruent to segment CD, because that's just what a midpoint is. And it also says FG bisects AE. So if this is AE, and this line here bisects it, then we know that this segment is equal to that segment. So we got that. So we want to find as many congruent things about these triangles as we can. Now we also have these vertical angles here, and so these angles are congruent because they're made of the same two lines that pass through. So we have here a side angle side on each triangle, and so we're going to use the side angle side theorem to prove triangle congruence. So that is our strategy. So you always want to start with your strategy, and then you can start writing the proof. So to use this theorem, you have to write a statement that proves congruence for each of these things. So let's start with the statements. The first statement is the given statement. So C is the midpoint of BD, and I'm abbreviating a little bit here, and FG bisects AE. I wouldn't normally abbreviate this much, but I'm just limited on space here. So that's given. So I need to somehow show all of these congruent statements. I need to show that BC is congruent to CD. So I'm going to say, hey, BC is congruent to CD. I need to state that for this proof. I say, why do I know that? Well, because C is the midpoint, and so my reason is that it's the definition of a midpoint. Because by definition, if C is a midpoint, then BC must equal CD. I need to say that AC is congruent to CE. That was the second thing I said. And why do I know that? Because it says FG is a bisector, so this is going to be definition of a bisector. So those are our two statements so far. I need to show that these angles are congruent, so I need to say that angle ACB is congruent to angle DCE, and the reason for that is the vertical angle congruence theorem, that vertical angles are congruent. And now that I've said all that, I can say that this triangle ABC is in fact congruent to triangle EDC. And again, just to do it correctly, I need to make sure I'm using the same orders. If this is A, B, C, so A is the one that is at the one with two lines, and here, so that's E. So A is corresponding to E, then it goes to D, and this goes to B, and then they finish at C. So you have to choose the same order. So if you start here at the intersection of 2 and no lines, then you go to the intersection of 0 and 1 line, and then you go to the intersection of the 1 and 2. You're going to do the same order here. So ABC is congruent to EDC. And the reason for this is the side angle side theorem. And that is how we write a triangle proof. They're all very similar. You might use a different theorem in different circumstances, but it's all about proving sides congruent, proving angles congruent, and using the correct theorem. And that is it. So until next time, I am Derek Genova. Have a delightful day.